class, and I'll just do it here. All right, so what we've done is we've kind of taken a bunch of, we took an isometric and then did a little rotation back to orthographic, and then made blocks of the orthographic projections, a couple of faces. We brought the blocks in and kind of related them to each other. At this point is going to be the first time it might behoove you to go to 3D, but I'm a little bit worried about, you know, people thinking it's 3D, but it kind of is. So here's what I'm going to use. I'm going to let you know that rotate 3D and 3D rotate seem to be the same command, but they're not. Let's see which one is right. Rotate 3D. Okay, that's the kind of the one I think you want. The one you're looking for is this. Grab your objects you want to tell it the 2 points on the rotation axis. So 2, typically if you notice there, the capital letter in any of these things is your choices. 2, first point on axis is the end point there. Second point is the end point there. You got your thumb out going up and down. You want to rotate, so you're going to rotate actually positive 90 degrees. It didn't go away. It went into the board or into the plane. I'll do that again this time. I'll do it this time with the other way. I'll rotate and think about my rotation axis going the other way, so I know I have to do negative. So I'm going to do this. Rotate 3D. Grab my objects. 2 points. Now I'm thinking about the axis here. Endpoint there. I'm running my thumb along the axis, and I need then to take my fingers the other way, so this is going to be a rotation of minus 90. Right? V point 1, 1, 1 takes you to a viewpoint, and you kind of see what's going on there. At this point, if you fill in, and I think some of you are doing it, you go ahead and fill in from endpoint to endpoint, you'll actually be drafting in 3D. And so if you've noticed the difference here, now that I kind of laid that out and did those rotations, I've got all that stuff on the plane. The reality is, bringing in this nice little orbit tool, you see how that one that I just drafted, even though it's a shell, it actually is 3D. And so the kind of things, if you're doing blocks, and again, we're just pointing you towards the fact that this is where you go between 2D to 3D, and you can use some of your skills. And so you could then start doing things like left click. That one doesn't work for you. You can do left click, spacebar, 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 spacebar. Move, you want to C for copy. You want to change your B for base point. Your new base point is the end point over there. And then you can go ahead and change it to the end point there. And in that, you pretty much have what's left. Shift right click, end point. I'm not telling you to draft much like this. I'm just telling you that's to show you how projections start to work and all the graphics involved. So right there, if we're moving this thing around, it's worth at this point. I'm going to tell you, many of you have started to see, I believe, different engines that are out on the web, like SketchUp, like even some of the AutoCAD products that are put out for free, how much the 3D thing is coming. I'm just using endpoint to endpoint there. And now I kind of have my face done in a wireframe. Of course, we're going to go back in a second, and since we're going to use the full time here, go back and show you, in fact, how you go about going to make this 3D thing without doing so much work. And so let me go back, show you a great command when you go out. One command is as soon as you start getting out of 2D is to learn how to type plan. It takes us back. If you remember this, this actually is the 3D thing, so I'm going to do a new layer. Do this. I'm going to make a new layer. I'm going to call it 3D frame. So basically that's just a bunch of lines, or wireframe. I guess I can call it 3D wireframe. And I'll go ahead and change that layer, its color, to something that we haven't used lately, which will be yellow, which means now when I put things on this thing, we'll keep track of it. It being, of course, hopefully on 3D wireframe, which is not yellow. Take all that, change it to 3D wireframe. Now, I'm going to double check, right click, properties, what should be the color of everything? Everything should be 3D wireframe. I'm going to point out at this point in time why everything's screwy, because I broke my rules on blocks. I did not define my blocks on layer 0, so I'm going to grab all that, and I'm going to go right click. It will let me explode multiple blocks, I think. And now I'm going to grab all that, right click, properties, and change the layer to 3D wireframe. So as I break rules, and now of course 3D wireframe, we haven't changed the color of the layer yet, so we're going to say layer. 3D wireframe is supposed to be, we were going to make it yellow. So again, that rule about making things that you want blocks generally to think first about putting them on layer 0 so that they can become, you know, the universal chameleon. Once again, every time you break these rules, you remember this here, this in fact was what? This was an isometric view because it came from what this became from it. We made it on layer 0. This was an isometric view, so I'll go ahead and make a layer. And I'm going to go here, isometric. You wouldn't have all this going on in one drawing, but if we try to organize this stuff now, we'll be able to do a little bit of comparison. The isometric was really a 2D set of lines. It was projected on a plane. Isometric will make it purple. And that was not a block. If you remember, that was a B poly. That was actually a polyline. When you do a region, it makes either a block, makes either a polyline or a region directly. I generally like to go through the polyline and then make the region myself. I'm going to put that on isometric. Right? If you remember this here, this basically was the projection of that when we came about it, and that was a plat. We'll just get rid of that. That was for the area. All right, so what do we have here? Well, we got a bunch of stuff, 2D projections. We actually got something that's 3D out here. But in reality, how do we really do it? Well, again, I'm going to redo what I did before. You make a new layer sometimes, and then you're going to do something like this, maybe your regions. I'm just going to make a new regions layer. I'm going to go ahead and put that as a color like blue in the short term. Hit OK. Set my 3D regions to be my current. So when I do something like this, B poly, I'm putting lines on top of lines. B poly. I go ahead and pick my points, and I could immediately go to region if I want. Pick points. I now have a region. Now I've got my regions. I might want to isolate that layer. So how do you isolate layers? Well, all kinds of different ways. That's the way right there. Isolate that layer, everything else depending on your settings. And now you have a region which you can then extrude. You can extrude that and push it back maybe -4 or whatever it is. V.1, 1, 1. Shade if you want to look at it. Now you've got something that has mass engineering properties, especially for those who are in renewable. It has thermal conductivity. It has thermal specific heat, depending as you want to go ahead and do this. And you can see that by saying mass prop. That's the difference between extruding out shells. You see it has all kinds of stuff there. And when you're using mass prop, it's really a good idea very quickly to change your units so you get something that makes a little bit more sense to architectural. Don't know why AutoCAD does that, but in fact when you list that, when you say mass prop, which is on the inquiry toolbar, and you grab that there, you see everything comes in some units that start to make sense, cubic inches, that idea of a bounding box, even though it made Jamie and a couple other people a little uncomfortable, but by golly, understanding that if you can keep track of when things, bounding boxes are not in the same space, you save the mathematics of computation a lot of time. The centroid, the moments of inertia, products of inertia, radius of gyration, and the principal moments. All important things when you're trying to do engineering on things, not just drafting. Now I'm going to turn everything on because I isolated and I can unisolate. There's all my stuff. There's all the stuff. And so you start to see you can get the same isometric type views just by playing around, right? Right? In other words, you could eventually figure out mathematically what view got us this actual view here of the light box. So right there you see this one here. The yellow is the wireframe, which we did by making blocks and bringing them in after first turning things down. So there's a lot of intense stuff in here, but this is mostly for those who have got some really good, done some good isometric drawing that they can scan in, go over the top of, and then do a little morphing and getting into 3D. Once again, I will point out that what you would like to do is if you're going to draft by hand, draft in an orthographic view, scan it, bring it in, and do some of these extrudes and the like. So that's more than we bargained for. Of course, we always want to go back to plan And you can see how much is going on in this drawing. We can do a lot more, so let's finally take you back. V point is the way I like to do it. It shows you vector. It takes you, where is your eye? My eye is here. I can, at some point, don't want to do this, I can turn on the dynamic UCS. Those of you who have been using SketchUp know that that's kind of inherent in that. I can draft a circle here, there. I can now say extrude the circle, and I can extrude it -2, and then I can do, I'll see that's a circle. I think I need to make it a region, so I'm going to do a region. I'm out of time. See ya, bye.